Hello, my dear children. Welcome to the mathematics class. Today we are going to discuss statistics. In this chapter, we have discussed mean deviation and standard deviation in the previous exercise. I hope you have understood the concepts of mean deviation and standard deviation. They are said to be measures of dispersion. And I hope you have learned well the problems related to mean deviation and standard deviation. Haven't you, my children? Right. Now come to the concepts of exercise 15.3. Are you ready to listen the class? Right. In this exercise, we mainly focus on comparison of two frequency distributions. Okay, my children. In earlier sections, we have studied about some types of measures of dispersion. The mean deviation and the standard deviation have the same units in which the data are given. Okay, my children, you have calculated mean deviation and standard deviation for a given data. Whenever we want to compare the variability of two series with the same mean, which are measured in different units, we don't merely calculate the measures of dispersion, but we require such measures which are independent of the units. Okay, my children. The measures of variability which is independent of units is called coefficient of variation, and it is denoted by capital letter C dot capital letter V dot. This notation denotes coefficient of variation. Okay, my children. Now we define coefficient of variation. The coefficient of variation is defined as CV is equal to sigma by x bar into 100, comma x bar is not equal to 0. Please remember this formula, my dear children. To calculate coefficient of variation of the given data, sigma by x bar into 100, where sigma and x bar are the standard deviation and mean of the data. Okay, my children, right? For comparing the variability or dispersion of two series, we calculate the coefficient of variance for each series. Okay, my children, for comparing the variability of two series, we calculate coefficient of variance for each series. The series having greater CV is said to be more variable than other. The series having lesser CV, that is coefficient of variance, is said to be more consistent than the other. Is this point clear, my children? Right. Now come to the next point. In this point, we are discussing comparison of two frequency distributions with the same mean. Okay, my children. Let x bar and sigma 1, let x1 bar and sigma 1 be mean and standard deviation of the first distribution, and x2 bar and sigma 2 be the mean and standard deviation of the second distribution. Okay, my children. Then coefficient of variance of the first distribution is equal to sigma 1 by x1 bar into 100. Yes, sir, my children. Similarly, coefficient of variance of the second distribution is equal to sigma 2 by x2 bar into 100. Okay, my children. Here, the mean of these two distributions are equal. Okay, but still they are same. So x1 bar is equal to x2 bar is equal to x bar. Let us consider say. Okay, but still therefore coefficient of variance of the first distribution is equal to sigma 1 by x bar into 100. Let us consider this is result 1, and coefficient of variance of the second distribution is equal to sigma 2 by x bar into 100. Let us consider this is result 2. By comparing the equations, by comparing the results 1 and 2, it is clear from 1 and 2 that the two coefficient of variances can be compared on the basis of values of sigma 1 and sigma 2 only. As for the children, if we observe these two results, we can compare these two distributions by comparing the values of sigma 1 and sigma 2 only. Thus, we say that for two series with equal means, the series with greater standard deviation or greater variance is called more variable or more dispersed than the other. Also, the series with lesser value of standard deviation or lesser value of variance is said to be more consistent than the other. Is this point clear, my children? Right. To understand these concepts well, let us take some examples. Okay, my children, let us now take following examples. See this example. Two plants A and B of a factory show following results about the number of workers and the wages paid to them. Okay, my children, see here this is plant A and this is a plant B. Number of workers, here 5,000 workers are there in the plant A and 6,000 workers are there in the plant B. Average monthly wages, here 2,500 rupees, here also 2,500 rupees. That means mean of this first plant and mean of this second plant are equal, same. Okay, my children. Variance of the distribution of wages of plant A is 81 and plant B is 100 respectively. Okay, my children. In which plant A or B is greater variability in individual wages? Understood this question, my children? We have to find the variability in the individual wages. Okay, my children? Right. Now come to the solution part. The variance of the distribution of wages in plant A, that is sigma 1 square, is equal to 81. Therefore, standard deviation of the distribution of wages in plant A, that is equal to sigma 1 is equal to 9, square root of 81. What will you get here? 9. Understood this step, my children? Right. Similarly, the variance of the distribution of wages in plant B, that is equal to sigma 2 square is equal to 100. With the help of this one, we can find the standard deviation of the distribution of wages in plant B, that is equal to sigma 2 is equal to square root of 100, that is equal to 10. Understood this step, my children? Right. Since the average monthly wages in both the plants is the same, that is 2,500 rupees. Yes or no, my children? Have you observed that point? Right. Therefore, the plant with greater standard deviation will have more variability. Thus, the plant B has greater variability in the individual wages. Understood this point, my children? Right. Now let us take another example. Coefficient of variation of two distributions are 60 and 70 and their standard deviations are 21 and 16 respectively. What are their arithmetic means? Understood this question, my children? Here, coefficient of variations of two distributions are given and their standard deviations are also given. We have to find means of the two distributions. Okay, my children? Right. Come to the solution part. Given coefficient of variation of first distribution is equal to 60 and standard deviation of the first distribution, that is equal to sigma 1 is equal to 21. Similarly, coefficient of variance of the second distribution is equal to 70 and the standard deviation of the second distribution, that is equal to sigma 2 is equal to 16. Okay, my children. Let us consider x1 bar and x2 bar be the means of first and second distributions respectively. Okay, my children. Then here we wrote the formula. Coefficient of variance of the first distribution is equal to sigma 1 by x1 bar into 100. Okay, my children, do you remember this formula? Yes. In this formula, let us substitute the values of CV and sigma 1. What is the CV here? 60 is equal to sigma 1 value is 21 by x1 bar into 100. Understood this step, my children? Right. From this equation, we are finding x1 bar. So x1 bar is equal to 21 by 60 into 100. Okay, my children. Right. Here, let us simplify these two numbers. Here 0, 0 gets cancelled. 0, 0 gets cancelled. Here 2, 3 times and 2, 5 times. Okay, my children. Here 3, 1 times. Here 3, 7 times. So 7 5s are 35. Understood this step, my children? Right. Similarly, coefficient of variance of the second distribution, that is equal to sigma 2 by x2 bar into 100. Similarly, in this equation also, let us substitute CV of the second distribution and sigma 2. So that is 70 is equal to 16 by x2 bar into 100. Understood this step, my children? Right. From this equation, let us find x2 bar. So x2 bar is equal to 16 by 70 into 100. Now let us simplify these numbers. Here 0, 0 gets cancelled. Okay, my children. Then what will you get? 16 by 7. 16 by 7. Divide 16 by 16 into 10. That is 160 by 7. Okay, my children. Here we get 160 by 7. So divide 160 by 7. What will you get here? 22.85. Okay, my children. Understood this step? Right. Now let us take another example. The following values are calculated in respect of heights and weights of the students of a section of class 11. Okay, my children. Mean 162.6 centimeters and weight 52.36 kgs and variance here 127.69 centimeters square height for height, and for weight variance is 23.1361 kg square. Okay, my children. Can we say that the weights show greater variation than the heights? Understood this question, my children? Right. Now, to compare the variability, we have to calculate their coefficients of variation. Yes, sir, my children? Right. What is given here? Variance of height, that is equal to 127.69 centimeters square. Therefore, standard deviation of the height is equal to square root of variance. Yes, sir, my children? So that is equal to square root of 127.69. That is equal to what we will get here? 11.3 centimeters. Square root of 127.69 is equal to 11.3 centimeters. Okay, my children? Right. Also, variance of the weight is equal to 23.1361 kg square. So, for a weight, let us find the standard deviation. Standard deviation of weight is equal to square root of the variance, that is the square root of 23.1361 kg square. Kgs. That is equal to What is the square root of 23.1361? Yes, 4.81 kgs. Okay, my children, understood the system, right? Now the coefficient of variance of heights, standard deviation by mean into 100, that is equal to 11.3 by 162.6. Okay, my children, right, into 100, that is equal to, by simplifying these numbers, what will you get? 6.95. Similarly, coefficients of coefficients of variance in weights, that is equal to 4.81 by, what is the mean? 52.36 into 100. By simplifying these three numbers, what you will get here? 9.18. Now by comparing these two numbers, what will you observe? Clearly, coefficient of variance in weights is greater than the coefficient of variance in the heights. Therefore, we can say that weights show more variability than heights. Is this point clear, my children? Right.